There is a place in the universe where the future has only one direction. Not left, not right, not back toward the stars, only inward. You may fire the strongest engine ever built. You may send a beam of light, the fastest messenger nature allows. You may scream into the darkness with every signal your civilization has invented. Nothing returns. That place is called a black hole. But I do not want you to imagine it as a hole in space. That is too simple. A hole is an absence. A black hole is not empty. It is not nothing. It is a region where space-time has been curved so violently that every possible path forward leads deeper in. That is the real terror. A black hole does not merely pull on matter. It changes what escape means. Far from it, space behaves almost politely. You can move away from a planet, you can orbit a star, you can choose a direction and, with enough energy, leave. But near a black hole, the rules begin to tighten. Space and time stop behaving like a quiet stage and begin behaving like a river rushing toward a waterfall. At first, you can still resist, then the current becomes stronger. Then you reach a boundary where resistance no longer matters. This boundary is called the event horizon. It is not a wall. You would not crash into a surface. You would not see a glowing sign saying, "Point of no return." If the black hole were large enough, you might cross the event horizon without feeling anything special in that instant. But from that moment on, the universe has made a decision for you. Outside the event horizon, escape is difficult. Inside it, escape is not part of the future. Even light cannot get out. Not because light becomes weak, and not because something catches it like a net. Light still travels at the speed of light, but space-time itself is shaped so deeply inward that all future paths for light point further into the black hole. This is why a black hole is black, not because it is painted with darkness, because it removes every route by which light could return to your eyes. Now comes the first mystery. If nothing escapes, how do we know black holes exist? We know because the universe leaves fingerprints. A black hole may be invisible, but its influence is not. Stars can orbit something we cannot see. Gas can heat up as it falls toward the darkness. Matter can form a blazing disk around the black hole, glowing hotter than many stars before it disappears forever. The black hole itself gives us no light, but the universe around it screams. Imagine a silent king sitting at the center of a room. He never speaks, he never moves, yet every object in the room bends toward him. Every candle flickers because of him. Every path curves around his throne. That is how astronomers find black holes. They watch what the invisible object does to the visible universe. Gas and dust near a black hole can flatten into an accretion disk. In that disk, particles do not fall gently. They whip around at extreme speeds. They collide, heat up, and glow. Before matter vanishes, it may shine with terrifying power. In some galaxies, the region around a supermassive black hole becomes so bright that it can outshine the galaxy itself. We call these active galactic nuclei, and when they are extremely luminous, we call them quasars. The light does not come from inside the event horizon. It comes from matter outside the horizon, burning away its final freedom. Even the jets we see in some galaxies do not emerge from inside the black hole. Nothing climbs out from beyond the event horizon. The jets are launched from the chaotic environment around the black hole, shaped by magnetic fields, spinning matter, and extreme gravity. This distinction matters. A black hole is not a monster throwing things back out of its stomach. It is a place where matter outside the boundary can become violently bright before crossing into silence. Now ask the second mystery. What is at the center? Many people say the answer is a singularity, a point of infinite density where space and time break down. But here we must be careful. Infinity in physics is often not an answer. It is a warning. When our equations predict an infinitely dense point, they may be telling us that our current theory has reached its limit. General relativity is magnificent, but it does not include quantum gravity. At the center of a black hole, where density becomes extreme beyond imagination, we expect that a deeper theory is needed. So I would not say the laws of physics simply do not apply. I would say something more honest. Our known laws lead us to a place where they can no longer speak clearly. That is far more interesting. A black hole is not only an object, it is a question written in gravity. It asks, what happens when matter is compressed beyond every ordinary state? What happens when space-time curves without limit? What happens when the two greatest languages of modern physics, gravity and quantum mechanics, are forced into the same room? We do not yet fully know, and that is why black holes remain among the deepest mysteries in the universe. Now ask the third mystery. Where do black holes come from? Some are born from stars, not ordinary stars like the sun. Our sun will never become a black hole. It does not have enough mass. It will expand, shed its outer layers, and leave behind a white dwarf. But a much more massive star lives a more violent life. It burns through its fuel, building heavier elements in its core. For millions of years, fusion pushes outward while gravity pulls inward. The star survives because these two forces balance. But eventually, the fuel runs out. The outward pressure weakens, gravity wins, the core collapses. In a moment of violence, the star may explode as a supernova, throwing its outer layers into space. But if the remaining core is massive enough, no known pressure can stop the collapse. A stellar mass black hole is born. These black holes may contain several times the mass of the sun packed into a region only miles across. They are scattered through galaxies like dark ruins of dead stars. In the Milky Way alone, there may be millions of them. Most are quiet. Most do not glow. Most do not announce themselves. They drift through the galaxy like invisible graves. But not all black holes are born this way. At the centers of large galaxies, we find something far larger, supermassive black holes. These are not 10 times the mass of the sun. They are millions or billions of solar masses. Our own galaxy has one at its heart, Sagittarius, a star, a dark object of roughly 4 million solar masses. Think about that. 4 million suns hidden at the center of the Milky Way, not glowing like a star, not burning with fusion, simply curving space-time so strongly that stars nearby whip around it at astonishing speeds. We can watch those stars move. We can measure their orbits. We can follow their paths around something we cannot directly see. And from those movements, the answer becomes unavoidable. Something massive is there. Something compact is there. Something dark is there. A supermassive black hole. But now comes the next mystery. How did such giants form? A stellar black hole can be explained by the death of a massive star. But a supermassive black hole is too enormous to explain so easily. Did the first ones grow from smaller black holes merging together? Did they feed rapidly on gas in the early universe? Did some form from massive clouds collapsing directly, skipping the ordinary life of stars? The truth is that the universe has not given us one simple answer. It has given us evidence, clues, and a problem. We know supermassive black holes exist in the centers of galaxies. We know they can shape their galaxies through gravity, radiation, and jets. We know some existed surprisingly early in cosmic history, but how nature built them so quickly remains one of the great open questions. And this is what makes black holes different from ordinary mysteries. They do not only hide light, they hide history. When you look at a black hole, you are not seeing an object in the usual sense. You are seeing the edge of what can be known from the outside. You are seeing the boundary between information and silence. A planet reflects light. A star produces light. A galaxy contains light. A black hole denies light a future. That is why it feels almost supernatural. But it is not magic. It is geometry. It is the consequence of taking gravity seriously until the very end. The deeper question is not simply, what is a black hole? The deeper question is this: what does the universe become when gravity is allowed to win completely? To understand that, do not begin with darkness, begin with light. A black hole is invisible only because light cannot escape from within the event horizon. But outside that boundary, light may do something even stranger. It may bend, it may loop, it may circle the black hole before escaping toward your telescope. This is why black holes can create some of the most beautiful images in astronomy. Not because the black hole shines, because the universe around it is being tortured into light. Matter falls inward, gas heats up, magnetic fields twist, space itself curves the path of radiation. A black hole becomes visible by forcing everything near it to reveal where the invisible center must be. If you could place yourself safely far away and look toward one, you would not see a simple black circle floating in space. You might see a glowing disk bent around the darkness. You might see the light from the far side of the disk, curved above and below the hole. You might see one side brighter than the other because matter is racing toward you at enormous speed. The darkness in the center would not be the surface of the black hole. It would be the shadow. A shadow made not by blocking light, like an ordinary object, but by swallowing every path light could take back to you. That is what makes a black hole so strange. It does not merely sit in space. It reshapes the paths by which space can be seen. But now ask a more dangerous question. If black holes are invisible, how did humanity ever become certain they are real? For many years, black holes were almost ghosts of mathematics. The equations said they could exist. The universe had not yet shown them clearly. A solution to the equations of general relativity suggested that if enough mass were compressed into a small enough region, space-time would close around it. At first, this sounded like a mathematical curiosity. An extreme result. Perhaps not something nature would truly build. But nature is rarely impressed by human hesitation. Astronomers began finding systems where a visible star seemed to orbit an unseen companion. The unseen object was too massive to be a normal star, yet it emitted no ordinary starlight. In some cases, gas pulled from the companion star became fiercely hot, producing X-rays before vanishing into the unseen object. The darkness had weight. The silence had gravity. That is how a black hole begins to move from theory into reality. Not by being seen directly, but by leaving no other reasonable explanation. This is a lesson repeated throughout science. The invisible is not automatically imaginary. You do not see the wind, but you see the tree bend. You do not see gravity, but you see the falling stone. You do not see the black hole, but you see stars orbit nothing, gas burn around nothing, and light curve around nothing, except it is not nothing. It is space-time bent so deeply that the center refuses to return information. Now move from one black hole to an entire galaxy. At the center of the Milky Way lies Sagittarius, a star, a supermassive black hole of about 4 million solar masses. Around it, stars move at extraordinary speeds, especially when they pass close to the center. Their orbits reveal a compact, massive object hidden in darkness. This is not a guess based on imagination. It is geometry measured in the sky. A star approaches the galactic center. Its path curves sharply. Its speed increases. Then it swings around and moves away again. Year after year, astronomers watch. The orbit becomes a written signature, and the signature says something incredibly massive is hidden there. The stars become witnesses. Their motion becomes testimony, and the verdict is a black hole. But Sagittarius, a star, is not alone. Nearly every large galaxy appears to contain a supermassive black hole at its center. Some are quiet, like sleeping giants. Others are active, surrounded by falling matter, blazing disks, and jets that stretch across enormous distances. This leads to a deeper mystery. Do galaxies create black holes? Or do black holes help shape galaxies? The answer may be both. A supermassive black hole is tiny compared with the full size of its galaxy, yet its influence can be enormous. When it feeds, The surrounding region can release incredible energy. Radiation and jets can heat gas, push material outward, and affect how new stars form. The black hole at the center is not simply a dark passenger inside the galaxy. It can become part of the galaxy's evolution. This is why black holes are not just dead ends. They are engines of change. They destroy, yes. They swallow, yes. But around them, matter can glow with astonishing power. Around them, galaxies can be shaped. Around them, physics is pushed to its most extreme limits. And still, the event horizon remains silent. That silence is not weakness. It is the rule. No telescope can see what happens beyond it. No signal can climb back out. The event horizon marks the edge of what the outside universe can know. This is why black holes are not merely astronomical objects. They are boundaries of knowledge. A star may hide its core, but light still escapes from its surface. A planet may hide its far side, but you can orbit around it. A black hole hides something more absolute. It hides events themselves. That is what the name event horizon truly means. It is not only a place, it is the limit beyond which events can no longer become part of our universe's story. If something falls beyond that boundary, the outside world may remember that it fell. It may measure the mass, the spin, and the charge left behind. But the detailed story of the falling object disappears from view. A book thrown into a black hole does not send back its final pages. A clock thrown into a black hole does not report its last tick. A human being crossing the horizon would not broadcast the final answer from inside. The universe closes the door. And this is where the deepest conflict begins. Physics is built on information. To understand the world, we track causes and effects. We ask where something went, what state it entered, how it changed, and whether the information about it still exists in some form. Black holes challenge that instinct. They ask whether information can be hidden forever. They ask whether space-time can create a prison so perfect that even the past becomes unrecoverable from outside. This is why black holes have troubled physicists for generations. They are not just heavy objects. They are tests. They test relativity. They test quantum theory. They test our understanding of time, information, and reality itself. And perhaps that is why they hold our imagination so strongly. A black hole is simple from far away. Give me its mass, its spin, and its electric charge, and much of its outside behavior can be described. Yet inside that simplicity is a mystery so deep that our best theories still struggle to speak. It is both the simplest object and the most disturbing. A star has layers. A planet has landscapes. A galaxy has billions of lights. A black hole has a boundary, a shadow, and a question. What happens beyond the horizon? The honest answer is we do not know in full. We know what general relativity predicts. We know that every future-directed path leads inward. We know that the classical equations point toward a singularity. But we also know that the word infinity often tells us that our theory is incomplete. So the center of a black hole may not be the end of physics. It may be the place where a deeper physics is waiting. A theory that unites gravity with quantum mechanics. A language that can describe space-time when it becomes violent and tiny at the same time. A language we have not yet fully mastered. Until then, black holes remain the universe's locked rooms. We can walk around the door. We can measure the weight of what is inside. We can observe how the door bends light and shakes nearby stars. We can even image the shadow cast by the room. But we cannot open it, not from the outside. That is the terror and also the beauty. Black holes are not mysterious because they break the universe. They are mysterious because they obey the universe so extremely that our minds struggle to follow. They take gravity seriously. They take space-time seriously. They take the speed of light seriously. And when those rules are pushed to their limit, the result is darkness with mass, silence with structure, and a boundary beyond which knowledge cannot return. So if someone asks what a black hole is, Do not only say it is a place where gravity is so strong that light cannot escape. Say this: a black hole is what happens when space-time curves so deeply that the future points inward. It is not merely an object in the universe. It is a wound in the map of possible paths. Outside it, stars can orbit, gas can burn, galaxies can evolve, and telescopes can gather clues. Inside it, every road leads away from us. That is why black holes inspire both science and fear. They remind us that the universe is not required to be transparent. It is not required to explain every event. It is not required to keep every answer within reach. Some places can exist where the question enters, and only gravity comes back. The most terrifying thing about a black hole is not that it destroys matter. It is that it changes the meaning of escape. It changes the meaning of time. It changes the meaning of what can ever be known. And somewhere in the center of our galaxy, a dark giant sits quietly, holding 4 million suns worth of mass, bending the paths of stars, and reminding us that the universe still contains doors we cannot open. Maybe that is why black holes feel eternal in our imagination. They are not just endings. They are the edge of explanation. A star dies, a core collapses, space-time bends, light loses every road home, and in the silence left behind, the universe writes one of its deepest messages. Reality is not always visible, but it always leaves a shape. Subscribe to explore more mysteries through the questions that still lead humanity to the edge of reality.